So we're going to get an IR on the purified distilled ester. Notice I'm sitting in the hot block, or a block, not the one that was hot, obviously. And I have my set of sodium chloride plates. I've already woken up the IR. So we have one nice plate and one slightly broken plate, but still usable. And then we have one very broken plate that's in here. It's actually a small and quite useless fragment in there as well. So as always, we kind of want to look and see if we can find the flatter of the sides, the one that looks like it's less damaged. This one looks like it's a little damaged on that side, but maybe not on that side, so I'm going to use that one. And then this one's definitely got a crack. The crack appears to be on this side, so I'm going to use the two sides that are not cracked. So we take a drop of this, stick it in the middle, and then stick this plate on top. So we get a nice film. The plates are definitely not flat, so we're getting a film, but it's not spreading out uniformly. Tilt that a little bit. Hopefully I can get that into the beam. So we're going to open up Omnic. And collect the background as always. Looks normal. Now we can get that in there. Trying to make sure that the actual film is in the blank region. It's definitely shitty plates. And that was 50B. So now we're going to collect sample. We'll actually have a -1 through -4 here because we're collecting the IR as -1, and then we'll have a proton NMR, a carbon NMR, and a DEPT. So there'll be 4 different spectra. So 4 scans. It's not a bad spectrum. We got between about 35 and 60. This is sodium chloride. So I'm going to save this. Set file name to title. And as usual, it's pointing at JOChem. And I have to change it. So it's pointing at mine. So I'm going to double click on here and I'm going to add a comment. Ester. Acetate ester, I guess. From unknown alcohol. Number, I believe it was 65. Move that out of the way. I will do a baseline correction this time because it looks like it could benefit from one. And hopefully you can see what I'm doing. Put that little gray box at the end. And then here, this is definitely baseline. is all sodium chloride, so I can make it all go away by defining it as baseline. It's an alternative to what one often does, which is to change the display limit so you're not seeing that stuff down that end. So I'm going to replace that and save it so I don't lose it. You'll notice the asterisk here in front of my name, which tells me that I've actually done something funky to this. I'm going to change my display limit so that instead of starting at 70, it starts at like 62. That'll make sure when I find peaks that I can still see the peak label. I'm going to find peaks. I actually want that little one there. So I got 2964, 2936, 2879. Those are kind of standard. 1460, 1390, those are also standard. This 1235 and 1041, you should know what those are. And I got a big peak at 1743. Certainly ought to know what that is. If you don't, drop the class, come back next year. And we'll move these so that they're nicely visible, out of each other's way. So that looks really nice. I'm going to save that. And I'm going to print it. Yes, I know caps are on. I meant them to be on. I put them that way. So we're going to do an IR spec interpretation. And it says it thinks it's a primary aliphatic alcohol, although there really isn't any peak there, so there's no reason why it should think that. An aliphatic acetate ester, that's a good sign because it is, and an aliphatic hydrocarbon. Right? So if I turn that off, you'll notice that there's overlap here between the aliphatic acetate esters and the aliphatic alcohols in this region, and this big region here where it thinks it's a primary aliphatic alcohol is mostly blank. Maybe there's a trace. So I'm going to print that. And we'll call that 50B1 functional groups. Maybe I don't want caps on for that. Close that up. And then we're also going to do a search. And you'll notice it comes up with some pretty strong matches. 94.73 to isoamyl acetate, 93.09 to amyl acetate, regular 1-pentyl, 90.33 to butyl acetate, 88.76 to propyl acetate, 86.41 to hexyl acetate. So these are not definitive because not every acetate ester of all the possible unknown alcohols is going to be in this library, but at least two 5-carbon acetates and 1 6-carbon acetate have showed up, which is good evidence that we probably have an ester. And all of these are acetate esters, so that's also a good sign. And we'll print that. Isoamyl acetate smells like bananas, not the only 5-carbon alcohol that does smell like bananas, of course, so that doesn't really, or 5-carbon ester that smells like bananas. So you can't use that as a definitive piece of evidence. Oops, what did I do? I lost my print window. Here it is. And this is the search result. I'm going to print that as 50B1-search. So we definitely made an ester. Probably it's a 5 or 6 carbon ester. Well, 7 or 8 carbon ester, 5 or 6 carbon alcohol that it came from. Save those changes, why not? Close up Omnic. Get this guy back to sleep. And take my sample out. So I'm going to now parafilm that up. I grabbed a piece of parafilm while you weren't looking. And store that in the freezer until such time as the NMR is working again, which will be another 3 or 4 weeks, I think. We get a service call. That's going to sit in there. And I just need a bottle of hexane to... That's open. And a bottle of hexane to clean the plates. We'll wipe those plates off to get rid of the ester, and then we'll just clean those on the hexane soaked rag. Make sure they don't smell like ester anymore. Not very good for winter skin, but oh well. Those guys back. Clean that off as well. The condenser and the Hickman still, I'm cleaning by sitting them there until they don't smell like ester anymore. Because the ester is volatile enough that it will disappear. The conical vial, obviously, I'll clean. And then this, since it had the pipette in it, is also just being left there until it doesn't smell like ester anymore. I don't usually like to clean those things with soap and water, the Hickman still, because they're hard to, it's hard to get them completely dry. It's also hard to kind of reach in there with a scrub brush. Anyway, so that's the ester, and we're just going to have to wait until the NMR is working to collect the rest of the data.